In this lesson, we're going to take a look at mass, volume, and just a little bit on weight. So, mass, volume, weight. We're going to look at units and we're going to look at the difference between these two. Now, I'm going to start by thinking about that experiment we did where we heated baking soda. We had a little rubber stopper in here and we had this in a little tube, and our little tube ran up into a bottle that was full of water. This is why I'm a teacher and not an artist. And this was inverted in our container. Now, when we heated this up with fire, gas bubbled out of this and pushed into here and pushed out the water. So water was in here and gas was in here. And this looked like mostly empty space because we couldn't see the gas. And we started with this little bit of solid in here, but it was definitely solid, it was full. And somewhere in the liquid we have somewhere in between, right? So the question we've been answering and trying to answer is, how does this amount of baking soda over here compare to the little bit of liquid droplets we got on the condensation and the gas we have over here and the baking soda powder stuff that we had left? And if we just look at volume, the volume of this is much larger than the volume of that. And if we think about why, it's because this is a gas and those particles are spread out more, and so they take up more space. And so as this changed and we had this gas emitted, the volume changed. But what about the mass? Well, mass is an amount of matter, right? So volume is an amount of space occupied. And of course, we remember that that's measured in milliliters or cubic centimeters. Mass, on the other hand, is an amount of matter. And it's going to be more closely related to the number of particles there than how those particles are arranged. Whereas volume is more about the arrangement of the particles and less about the number. Now, mass has units of grams or kilograms. Be careful with that because we know a milliliter and a cubic centimeter are the same, but it turns out there are 1,000 grams in 1 kilogram. Now, a gram is a very small amount of matter. If you've ever picked up a small paperclip, you've held about a gram of mass in your hand. A kilogram is considerably more than that. So a kilogram weighs 2.2 pounds. Now, kilograms and grams are metric units. A pound is a British unit or an American unit, and they actually describe slightly different things. Weight is due to the pull of gravity, and mass is due to the number of particles. And so the two are not the same, and we are focusing on mass for now. So don't report things to me in terms of weight. We're not weighing things, we're massing things. We use a balance to measure mass. So keep that in mind. But because we're on Earth and the gravity on Earth is constant, if I know something's mass, I can figure out its weight. So if I want, I can say weight is equal to mass times 2.2. Now this is weight in pounds. Pounds gets the abbreviation LBS, and this is mass in kilograms. You can also use this the other way around. If I know weight, I can divide by 2.2 to get mass. And I can show you that equation. So weight equals mass times 2.2. If I divide this side by 2.2, I have to do it to the other side. So divide by 2.2. And what I get is weight in pounds divided by 2.2 will get me mass in kilograms. Okay, that's only true on Earth because that's the relationship between mass and Earth's gravity, but that is how weight and mass can compare.